Hello friends, welcome back. I am Rajneesh and today we are going to understand the udev service. If we talk about the older kernels, that is 2.4 and below that, we used to have static device nodes that were created at the time the machine boots. So finally you had a lot of devices that were created and were present even if they were physically present or not. But if we talk about kernel 2.6 and later, what has happened is devices are dynamically created as soon as they are attached. And additionally, you can manage the devices with udev. You can specifically provide this device a particular name. You can modify the permissions dynamically as soon as that device is attached. So we are going to discuss about udev, which is user space device management. So first thing, what is udev? Udev has a package associated with it, which is udev itself, and a service is udevd that runs in the background, and that takes care of u events. So this is basically a device manager for Linux kernel. What it does, it manage device nodes. So for example, as soon as you attach a USB disk, you can set it to have a particular permissions, like it can be written only by the user. You can set a particular user to it. For example, as soon as you attach a USB disk, it should be owned by my user rcval. It should have permission 600. And even to better understand the disk, for example, if I am attaching 4 or 5 USB disks, I need to understand which is my disk 1, which is my disk 2. So I can just create a symlink, and that will be created dynamically using udev, and that can have a better understandable name which lets you know which is the disk that corresponds to. So we'll have a lab for it. So it's the successor of devfs and hotplug, which we used to have in 2.4 kernel. It handles the dev directory and all user space actions when adding, removing devices, including firmware load. So as soon as you attach or remove a device, some actions can be performed. So that's how it happens. As far as devfs is concerned, we used to have static device nodes present in that. But as far as udev is concerned, the devices are created dynamically. udev runs in user space. It dynamically creates, removes device files, provides consistent naming. For example, you have 4 disks. The name SDA, SDB, SDC and SDD is going to depend upon the sequence that you attach them with. The first SCSI disk attached is going to be SDA, the second attached SCSI disk SDB. So if you attach second at the first, the sequence will be changed. To understand them better, they should be named in a better way. For example, disk 1 or your gaming disk, music disk, something like that, so that you can understand them clearly. It provides user space API that can be used to specify specific permissions, user, group, ownership, names, symlinks, etc. Okay, with 2.6 kernel, there came a new file system which is known as sysfs. So as soon as a device is attached and kernel understands that device, sysfs, the file system which is mounted under /sys folder, is exported or populated with the complete details of that physical device. So, and as soon as this device is attached, first thing is sysfs is populated. The second part that happens is u event happens, and udev listens to the u event and takes care of proper actions that needs to be performed. We'll see in example, and I hope that should be able to make you clear what exactly happens. So first thing that happens is you attach a device, you attach a USB disk, kernel detects it, it populates sysfs with the device details, its serial number, where it is, its location, what kind of device, and the complete details, vendors and everything. Now, kernel triggers a U event. U event is listened by udev, and udev now have a look into sysfs and checks whether we have a particular rule corresponding to that device. If it matches our rules, rules are present in the folder /etc udev rules.d and star.rules. Make sure that the names end with star.rules or with dot rules, otherwise they won't be considered to be used. So it's going to match all the rules present inside this folder and see whether any rule matches the device which is just attached with or just removed. If it matches the rule, then it performs the required actions. For example, naming of a device, creating a symlink, etc. So it checks the rules against various device attributes to identify the device and create meaningful symlinks, set permissions, rename device, or run a script. Okay, with this we complete with the presentation, and let us now move to our two virtual machines that we have. One is 192.168.1.123, the same machines that we were using in the previous session, where we created iSCSI target and iSCSI initiator. So it's the default password that I use only in test machines. Okay, so if I type the command fdisk -l, I see that I have a device dev sdg. Okay, this is actually the same device that we created in the last section, and right now you can see that the same device 200 MB is named as dev sdg. So we should have something which says the device should be named in a better way. For example, in this scenario, let's rename the device that we are receiving from iSCSI target as iSCSI and its partition as iSCSI 1, iSCSI 2, something like that, so that it will be better understandable. So how do we do that? df-h, here you can see that it was named dev sdg because the device was removed while it was mounted. So the next time it tried to use a different name, I just unmount it. Okay, so iSCSI adm minus mode is node, target name, portal, and I just log out of it. fdisk -l grep disk, and I can see that I have the disk still dev sde. Now I log into it and I'll receive a new disk which is now dev sdf, and if I see fdisk -l dev sdf, it has one partition which is around 200 megs. Do we see something mounted? No. So this lab is going to be about creating a symlink for the device, so that it will be named iSCSI and the partitions inside it will be named as iSCSI 1, iSCSI 2, something like that, so that we can understand that these are iSCSI devices. For your case, you could keep different names like my iSCSI from this server or whatever name you find good. So how do we do it? There is a folder, and before that we need to understand the details of this block device SDF. udev, the commands associated with this udev ADM monitor is the command that can be used to see what actually is happening, what are the events happening. Let me create a new session and I'll show you. I'll show you how the events happen. udev ADM monitor -env will displace the environment variables. So what happens? iscsi ADM, and I am going to log out of the portal, which says a device will be removed. And here you can see what actually happened. These all were the events or the actions that happened. First, kernel received a message to remove it. At that particular instance, you received a kernel event which was to remove it, remove a USB device. So you can specify a particular action that can be taken when it's getting removed. So these were the actions happened after that. Device paths. So here you can see the complete details. Now if you try to add it, or you just try to log in into it, you'll see a few more events are going to happen, and a lot of events can be seen which are all corresponding to the action that was performed by udev to add this device. And initially it happened that kernel added a device dev sdf1, which was a block device. So kernel added dev sdf1, and then udev received and udev added this device path. Subsystem is SCSI because it uses SCSI commands over IP. So udev adds it. Now here you can see other informations related to your device. If you forget about monitoring, you can just check out the details of a particular device while it's already present. So how do we do that? udev ADM -help. So info to get information about it, query equal to all. We are going to query all the informations about a particular device. Path. Path, if you specify, is the path inside sysfs or inside sys folder. So it's going to be sys block sdf, and removing /sys from it. So it's actually the path inside sysfs or inside sys folder. So I ran the command query equal to all, query all the details of the device dev sdf. So here we see all the details. Okay, E corresponds to environment. P specifies the path. Let me just confirm udev ADM. Sorry. Okay. So udev info. Okay, udev info query equal to type, which specifies you whether it has certain symlinks, path, property, all. So what we are going to do is, what we have fetched is all the attributes. Path is complete path, name is the name of the device, symlink, and it should display you devices, subsystems. Okay, these are these that start with E are all environment variables that are provided or that are available in sysfs, and udev can take action on it depending upon these environment variables. S stands for symlink. If you want to confirm ll dev, and here you can see that this is a symlink which points to the actual device dev SDF. E is the environment variable, and yeah, so the actual device is uh, sorry so the actual device is the SDF, which is it says over here. The symlinks that are created are capital S. The name of the device is SDF as received by the kernel, and E are the environment variables. Okay, so now our objective is, as soon as we receive this SCSI device, it should be named or symlinked as iSCSI, and all the partitions inside them or inside this partition should be named as iSCSI 1, iSCSI 2, the same as in case the device is SDF, first partition is dev SDF 1, second dev SDF 2. In the same way, the device will be iSCSI, partitions will be iSCSI 1, iSCSI 2. So let's create our first rule. /etc udev rules.d ls. We can have a look into some example before that. So here it says, okay, let me copy it. It's actually very simple. So I'm going to create a new rule. The rules are interpreted on the sequence of these numbers. First 60, then 70. If it's 70, then C comes first, 70 CD, then 70 net, and then 91. So we want it at the end. 90 custom dot rules, and here what we are going to do is, first thing that we have to check is, or we can just copy it, subsystem. So subsystem is going to be block because this is a block device. Environment variable, we can check out some environment variable which we know is going to be constant corresponding to a particular iSCSI target. So if we are talking about this one, this is going to be the same corresponding to every it's going to be a unique value. If we are talking about what we are importing from iSCSI target, so let's use it iSCSI target serial number, that's this one, and create a symlink, plus says create one symlink. In case they have been previously created, it's fine. Create a new symlink which will be named as iSCSI something, or you can just mark it as my iSCSI something. So okay, we missed one thing. Action equal to add. So it means whenever kernel receives a message or an action to add a device, and that device is required to be added to is of type block device, and which has the environment variable iSCSI serial as BEAF11, create a symlink. So okay, now I'll log out from it, or before that dev my ISCI star, there is something nothing like it. I am going to log out of it, log out of the iSCSI target, and if I type fdisk -l grep disk, I cannot see dev sdf because that's just removed because I logged out of the SCSI target. Let me log in again, and here I can see that dev sdf is now created. Fine, but how do we know which is this device? Because we created an udev rule which says whenever we receive a LUN or whenever we log in into a LUN from this particular iSCSI target, let's name it as myscsi something. So ll dev, okay, there is some issue with my rule. Dev okay, so I see that the rule didn't work. '90 custom.rules, it's fine, permission is fine. So action, sorry, actually I'm comparing or checking out what is the action that is performed. So in case you are comparing a variable, it should be double equal to. In case you are assigning a value, it should be single one. For example, as we are creating a symlink over here, let me log out of it and log in once again. And here you can see that your my iSCSI and my iSCSI1 are created. And if you type fdisk -l, it will display you that it has one partition which is my iSCSI1. Okay, and if you want to confirm, it's a symlink corresponding to the device SDF. In the next time, it could be if you have attached one USB disk and that comes out to be SDF, and then you try to log in into this iSCSI target, it may come out to be SDG or something like that. But still, there will be a symlink which is dev my iSCSI, which will point to that iSCSI LUN that is mounted. Now, if we want, we can do one more thing. Let me log out of it. So as soon as I log out, the device is also removed. Symlink is also removed. Now, my objective is as soon as this device is mounted or this device is scanned or this iSCSI initiator logs into that particular LUN, that device should be mounted automatically. How do we do that? So for that, I'm going to come again with the same custom rule, and I'm going to add one more line which says whenever there is an action to add a block device which is corresponding to this LUN, Let's run one more command which says mount. Okay, which says mount, and here you can specify the complete command or just ISCSI. So as soon as a block device is detected and it creates a symlink for it, it can be mounted automatically under iSCSI. I'll show you how. etc fs tab. The second thing that we are going to modify it to make use of the name my ISCI, my iSCSI 1. This is the first device on my iSCSI LUN that we created in the last session. So it is going to be mounted on slash iSCSI. So this happens as soon as the device is detected. If I type the command df-h, till now it's not mounted. I am going to log out of it. It's already logged out. I am going to log in once again. And now if I type the command df-h, I can see that this device is mounted under iSCSI. So this is the way how we create rules in udev to assign it a particular symbolic link or to assign it a particular name. If you want, you can change the permission.